Hello everyone, welcome to today's session on areas related to circles. So in areas related to circles, we will look at the areas of sectors and segments. Okay. So earlier we learned what is a sector and what is a segment. So let me draw a circle here. Okay. So this is a circle, right, with the center O. And if I cut it like a pizza here, right? So this area is a sector. Okay. So this is a minor sector. And the other area, let's say this is touching at A and P, right? And I have, let's say, 2 points here, P and Q. Then OAPB, I can say it as a minor sector. So this one, OAPB, that means this one. So this is a minor sector, and OAQB, that's a major sector. Okay. Now, what is the area of a sector, right? So we know the total angle. The total angle in a circle is how much? Angle in a circle is 360 degrees, right? So angle in a circle is 360 degrees, the total angle here. Now, what is the area for 360 degrees circle? Area is how much? Pi r square, right? This is what we learned. So pi r square is the area for the total circle, which is 360 degrees. Now, this one, this sector may be just having some angle, like 30 degrees, 50 degrees, 80 degrees, 90 degrees, like that. So if it is a theta angle, then what is the area? This portion of area, right? So this portion of the area is a part of that total area, right? So how much it is? A fraction of the total area of a circle. So how much it is, right? So for theta degrees, right? The sector area, sorry, this is theta, right? For theta degrees, the sector area equal to, can I say pi r square by 360? That is for 1 degree, right? Into how many degrees this is? Theta. And if I rearrange this, I can say theta by 360 into pi r square. So this is the area of a sector. Understood? This is the sector area. So the sector area is a fraction of the total circle area. Up to what fraction this is? Theta by 360. If it is a 60 degrees, then 60 by 360, that means 1/6 of the area of the total circle. For example, I have a circle here, which I divided into 4 parts. Okay. So what is this angle? Each angle is 90 degrees, right? If I divide into four equal parts, then I can say these are 4 sectors. For these 4 sectors, each angle is 90 degrees. Then if I substitute, 90 by 360 means 1/4 into pi r square. So here, if I divide circle into 4 equal parts, each part area is 1/4 of the total area, right? So if the total area is 100 centimeters square, each part is 100/4, which is 25. So that's what we got here, right? So the sector area is theta by 360 degrees into pi r square. Okay. Now, what is the length? So we got the area now. So what is the length of this sector, circular path of this, right? So what is the, 1 minute. So what is the circumference of the circle or the perimeter? So the perimeter of full circle is, perimeter is 2 pi r. Okay. If it is for theta degrees, right? Only this portion, AB. So AB perimeter, right? So AB perimeter is that sector perimeter. So can I say that total perimeter is 2 pi r by 360 into theta? same as that. So I can write like theta by 360 into 2 pi r. So that is the perimeter of that sector, that portion of that sector. Okay. AB is nothing but that sector perimeter, right? This one. Total is 2 pi r. If we multiply with theta by 360, you will get that portion of that perimeter. So here, what we learned here, sector area is theta by 360 into pi r square, and sector perimeter is theta by 360 into 2 pi r. Okay, that's what we learned. And then we learned about the area of a sector and perimeter of a sector. Now let's look at what is the area of a segment. Okay, so in earlier sessions we learned, right? In earlier sessions we learned what is a segment, right? So let me draw a circle here. Okay, I'm drawing with free hand, so may not come accurate. Okay, now let's say this is a card. AB is a card. You understood, right? Now a card divides the circle into two segments, right? A card divides the circle into two segments. Let's say here a point P and here a point Q. Now I would say ABP is minor sector, right? You understood, right? This bottom portion. ABP, this bottom portion is minor sector, and similarly AQB, that's a major sector. Sorry, not sector, segment. Sector is that triangular shape or pizza shape. So if we draw a chord AB that divides the circle into two parts, the smaller portion, the bottom portion is minor, and the bigger portion is a major segment. Okay, so what is the area of this, right? So let's say how to find the area of this, right? So I will draw this lens. I'll join this OA and OB. And this is radius, right? OA is radius and OB is radius because A and B are the points on a circle, and the line joining the center of the circle and any point on a circle is nothing but radius. So OA is radius. So OA equal to OB equal to R. Can I say that? That's the radius. Now, can I also say what is this angle? Let's say if this angle is theta, right? Then can I say OAPB is a sector? OAPB is a sector, right? It's a minor sector. So we know what is the area of the sector, right? So area of a sector, or I can say the area of the minor segment equal to the area of the sector minus this triangle area, OAB triangle area, right? I want this. You understood? I want this area, right? The shaded portion here. So this area, can I say the sector area minus this triangle area, right? So therefore, area of minor segment, listen carefully. The area of minor segment equal to area of sector. What is that sector? OAPB, right? OAPB sector minus area of, what is this? OAB. You're following, right? Area of OAB, that triangle. So sector area, this is total, this area is the sector area minus this triangle area will give us the shaded area. That shaded area is nothing but the area of the minor segment. Understood? Similarly, what is the area of the major segment? The area of the major segment is nothing but total circle area minus the area of the minor segment, right? So therefore, area of major segment. So what is major segment means? See, if this is the circle and this is the segment AB and this is minor segment, then this is your major segment, right? The above shaded area. So what is this area? The total circle area minus minor segment area. I can do that, right? So that is area of circle minus area of minor segment. Understood? We'll see a few problems, then you will understand how to find that area for the minor segment and major segments. So here we are learning what is a segment. A segment is a uh, part of the circle which can be obtained by dividing the circle with a chord AB, right? If a chord AB divides the circle into two parts, that each part is called as a segment, and the smaller part is called a minor segment, and the bigger part or the larger part, that is called the major segment. So how to find that area? So what I did, I just joined the OA and OB, which is a radius. Now this is forming like a sector, right? So this sector area minus this triangle area gives you the minor segment area. So once you know minor segment area, major segment area can be the total area of the circle minus the area of the minor segment. Understood? So here, once we do one problem, you will understand how to solve those. Okay, let's move on to the problems. So far what we learned, the area of the sector, perimeter of the sector, that is theta by, yeah, this is what we learned, right? So area of the sector and perimeter of the sector. So area of the sector is theta by 360 into pi r square, and similarly area of the perimeter of the sector is theta by 360 into 2 pi r. And then we learned about what is a segment, what's a minor and what is major segment, and the area of the minor segment is nothing but area of that minor segment, minor sector minus the area of that triangle OAB, area of this triangle. And once you know minor segment area, the major segment area you can obtain from by subtracting minor segment area from the total area, which is area of the circle minus area of minor segment. Understood? Okay. Now let's look into a problem. So here problems can be little tricky, right? So don't get panic. Just try to understand how to apply the knowledge that we have learned. Okay, we know the knowledge of what is the area of the segment and perimeter of the segment, as well as area of sector and area of perimeter of sector. Now let's look at this problem. A horse is tied to a peg at one corner of a square-shaped grass field. So basically, what they are saying is there is a grass field which is in a shape of a square, and a horse is tied to the peg. Means at the corner, horse is tied, and it has some uh, what is it tied? Yeah, so it is tied to one corner of a grass field of 15 meters. So the square shape is 15, what is 15 meters, right? So this field is 15 meters each side, right? By means of a 5-meter long rope. Okay. So in a square grass field of length 15 meter, a horse is tied to one of the corners, which has a length of 5 meters rope with the help of a 5 meters rope. So when horse is tied at the corner, what it can do with 5-meter radius, it can sweep that area, right? So maximum it can go is 5 meters at any side, right? If the horse is, for example, if the horse is here, maximum it can go to this point. If the horse is going this way, so it can go to this point. And if it is here, here, here. So basically, when it is tied, this peg will act as a center of the circle. And then the horse can make a circular, uh, horse can move in a circular path. Okay, in a circular path. So this area horse can cover. But here, as this is a square field, it can cover the area of quarter of the circle, right? It cannot go the full circle because the field is only in the square shape and it is tied at the corner. So it can cover the first quarter, right? Or 1/4 of the circle from here to here. Understood? So if you understood that, then it is easy to solve this problem. Okay. Now, so basically, I'll tell you one thing, right? So if the field is there, the horse can move like this. Okay. Observe closely. You understood? If the field is throughout, then horse could move in this 360-degree angle because it is tied at the peg that will act as a center of the circle. As the field is in the square shape, so it can cover one fourth of the circle, that is quarter of the circle. Now, so what we need to find? A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by means of a 5 meter long rope. Fine. Okay. So I did not copy like what we need to find. So let me see what we need to find. This is from your textbook. Okay. So there are two things that it's been asked. Number one, the area of that part of the field in which a horse can graze. Area which horse can graze, right? So that's one thing we need to find. And what is the second thing? The increase in grazing area if the rope were 10 meter long instead of 5 meter. Okay. So we need to find increase in grazing area if rope equal to 10 meters. Okay. Two problems were asked. So here, what is first one? Area which horse can graze. So this is the area, right? This area, the area that I am shading now, that's the area that horse can graze. You all agree? So for the first one, the answer is, what is that area? 1/4 of the circle. So what is this circle area? We know. If the rope is 5 meters, that means, can I say this radius is 5 meters? Right? The radius of this circle. Let's say this is A, point A, and this is point B. That means OA and OB is the radius. So we can say OA equal to OB, that equal to 5 meters, which is the radius of that circle. Now, what is that area? Total area is pi r square, right? So the graze area. So horse can graze area equal to pi r square by 4. Can I say? Because this is only 1/4 of the circle, right? So, or you can say this is 90 degrees, right? In a square, this is 90 degrees. Or you can also write like theta by 360 because this is like a sector, right? This is like a sector. So theta by 360 into pi r square, where theta is 90. So 90 by 360 into pi r square. So 91s, 94s. So you'll get the same thing. That is pi r square by 4, or 1/4 of the area. Now, so what is that pi r square by 4? So pi value, let's say 22 by 7 into what is r? 5. So 5 into 5 divided by 4. So this can be 22 into 25 by 7 into 4, right? So whatever the value you get, so that will be your answer. So for the best interest of the time, I'm not spending time on the calculation. So if you do that, you will get the answer, right? So this will be like, or I can simplify further. So 2 ones and 2 11s. So this can be 11 into 25 by 7 into 2 is 14. So if you simplify, you'll get the answer. And as this is area, I should write the units are meter square. So this is the first one. Now let's look at the second one, grazing area, right? So the grazing area is, here the hint is 1/4 of the circle, right? Pi r square by 4. Now, increase in grazing area if rope is 10 meters. Okay. So let's say if the length is 10 meters, so it can graze up to here, right? You understood? So what is the increase in that area they are asking? So that means this area between these two sectors, right? So I can say increase in graze area equal to, let's say if this is a small r and this bigger one is capital R, that is 10 meters, right? Can I say pi capital R square by 4? That is the total area that it can graze when R is 10 meters. minus how much it can graze when it is 5 meters. That is pi small r square by 4. Can I say that? Because we just need to find the increase in the graze area. So total area it can graze when it is 10 meters minus total area it can graze when it is 5 meters. So can I write this as pi by 4 into capital R square minus small r square? So let's substitute the values, or let's keep in pi values. Pi by 4 into what is capital R 10 square minus small r is 5 square. So I can say pi by 4 into 10 square is 100, 5 square is 25. So 100 minus 25 is 75. Or I can write as 75 pi by 4. In place of pi, you can either substitute 22 by 7 or 3.14. If you simplify, you will get the answer, and that answer should be in meter square. Okay. So hope you understood, right? Here, by looking at the problem, you will be kind of confused, right? So here, very simple. When horse is pegged at one corner of a square, it can graze that circular path. Here, as it is a square field, it can graze only 1/4 of the circle. So the rope of the length of the rope becomes the radius. That's the clue you need. Okay. So when the length of the rope becomes the radius, then it can graze an area of pi r square by 4. Understood? So that we found, that's for the first one. And then what is the increase in graze area if that horse rope, the length of the rope is increased from 5 to 10. So when it is 10, it can cover pi r square by 4, where r is 10 meters. And when it was 5, it can cover pi r square by 4, that was 5, when radius was 5. So I just used capital and smaller for that. And in place of capital, I substituted 10, and in place of smaller, I substituted 5. So, and then I'm leaving the calculation to you. So basically, you understood the concept, right? So when a horse is tied to a peg, that means the hint is the length of the rope becomes radius, and whatever the portion that it has covered, that is kind of a sector. So here it is 1/4 of the circle, so pi r square by 4. Or if you follow the sector formula, theta by 360 into pi r square, here theta is 90. So 90 by 360 is 1 by 4. Okay. So like that, you need to solve the problems. Okay. Now let's move on to the next one. So this is little tricky one. Okay. So listen carefully. A round table cover has 6 equal designs. So if you see here at the corners, designs, these are the designs here at the corners. 1, 2, 3, 4, 5, 6. Okay. We have 6 designs at the edges. So that's the round table cover, which has 6 equal designs as shown in figure. If the radius of the cover is 28 centimeters, okay, if the radius of the cover is 28 centimeters, find the cost of making the designs at the rate of 0.35 per centimeter square. Okay, that's interesting. Let's see. So what I will do is, this is, if you look at that, it will be a difficult. So I'll make it easy by just doing this. Okay, let's say that's the center of the circle. Let's say this is A and this is B and this is the center of the circle O. Can you see this is a sector? O, A, and this area and B, right? O, A, this area, B and O. This is like a sector. And if you look at AB, that's a chord. This is minor segment and this is major segment. So it's a combination of both a sector and a segment. You understood, right? See, I'll tell you here. I'll just draw this by removing all the other 6 designs so that you will. Oh, okay, hold on. Okay, see now, guys. So can I say this point AB as a segment? This is a minor segment, right? And if I consider OA this and this is a sector. Now, if I want this shaded area, that minor segment area, what I need to do, we learned that area of this sector minus area of this triangle. So if I find that into 6 times I need to do, because I have such 6 designs, right? So that's how I'm making this problem as simple. So just consider this as a segment and sector. So I took one segment and sector, okay, and I'll find that minor segment area. So that one design area I'll get. Now I have how many such? 6. So divide with I'll multiply with into 6, so that I'll get this total area that needs to be designed. And also here the rate is given for per centimeter square. We need to use 0.35 rupees for design. So then we can calculate the total cost. So here the minor segment area I need to find. So first, what I need to find? Minor segment AB area. So what is minor segment AB area? What is this OA? OA is nothing but radius, right? So what was the radius given? 28. So this is 28 and this is also 28. Understood? Now, minor segment AB area is so this is like area of sector OAB, right? Minus area of delta OAB. You agree? That's what we learned, right? So the sector area minus this triangle area. So what is the area of the sector? Theta by 360 into pi r square, right? So that's the sector area minus what is the area of the triangle. So what is this? First, let's see what is the angle. We need angle, right? So how many such divisions are possible here? One, two, three, four, five, six. Six. That means total angle is 360 degrees, and one portion should be 60 degrees here. That is not given, but by looking at the figure, if you divide into the equal parts, then you will know this is 60 degrees. So if this is 60 degrees, right? And this is 28, and this is also 28. Okay. Now area of the delta OAB. So first, let's find that. Okay. So first draw this triangle OAB. OAB. So this is 60 degrees, and this is 28, and this is 28. And if I draw a perpendicular to here, then this becomes 30 degree and this becomes 30 degree. Do you understand? So each portion becomes 30 and 30. Let's say this is touching at C. Now OAC is a right angle triangle, right? OAC is a right angle triangle. So from delta OAC, I need this, right? Because what is the area of a triangle? Half into base into height. So I need the base. I don't know what is AB length, right? So let's find that. I need, I know this OA. OA is hypotenuse. So from delta OAC, can I write sine 30 equal to half into, sorry, why am I writing this? Sine 30 equal to, from this triangle, what is the opposite side? AC. So AC by OA. You agree? So sine 30 degrees from this right angle triangle, sine 30 is opposite side by hypotenuse. Opposite is AC, by hypotenuse is OA. Now, what is the AC? I don't know. What is sine 30? 1 by 2. 1 by 2 equal to AC by what is OA? 28. Then can I say AC equal to 28 by 2, which is 14. So if this is 14, these two are equal, right? This will also be 14. That means this is 28. So this is an equilateral triangle basically. So this is an equilateral triangle with 28 side. So what's the formula for equilateral triangle? Root 3 by 2 A square. Here A is R. You understood? I'll tell the area here. What is the area of the triangle? Half into base. What is base here? R into height. What is height? Root 3 by 2 R. If you do this will become root 3 by, so this is basically root 3 by 4 R square. Okay, root 3 by 4 R square. You understood? So I got the area of the triangle by using half into base into height. Half into base is radius, nothing but radius, same length. It's an equilateral triangle into height. So if this is R by 2, then using Pythagoras, I can find this as root 3 by 2a. Okay, 3 by 2a. And if I substitute that, then half into base into height, which is root 3 by 4 R square. Now, so what is theta here? 60 degrees. So 60 by 360, pi I'll keep as is, into what is R square? R is what? 28, right? Or I can take that common. Okay, I think I can take that common. So I'll leave as is. And then root 3 by 4 R square. So 61, 66. So what it is becoming actually pi R square by 6 minus root 3 by 4 R square. Or I can write this as R square into pi by 6 minus root 3 by 4. Okay, if you substitute the value for R is what? 28. So 28 square into pi is, pi value is not given. You can substitute 3.14 here. So if you simplify, you will get some value. Okay, so that value, right? That value is your minor segment area. What is that minor segment? Your one of the designs on that table. Now, what is that total design on the table? Total design equal to 6 into this value. 6 into minor segment area. Minor segment AB area. You understood? Because we have 6 such designs. 1, 2, 3, 4, 5, 6. So 6 into minor segment AB area. So whatever the value you get, that you can see, that you can simplify. So once you get that, now you have total area of the design required. And the cost is given as 0.35. So what is the total cost then? So the total cost becomes this total design area into total design area into 0.35. So if you calculate that, you will get the answer here. What will be the total cost? Okay, so here I am helping you to get an idea how to solve the problems when a complex figure or the complex diagram is given, which has both a sector and a segment. First of all, to understand whether it is related to segment and sectors, we need to closely read the problem. A round table cover has 6 equal designs as shown in figure. Okay, if the radius of the cover is 28 centimeters, find the cost of making the designs at the rate of 0.35 per centimeter square. So first thing, I need to find the area of the total design, so that if I multiply with the cost, I can get the total cost. So how to find the area of this design, right? For that, I just took one sector, one portion. So I just indicated the center and then joined AB, right? So AB is a chord, so this becomes a minor segment, and OAB becomes a minor sector. Okay, so from this, from the formulas that I learned, the minor segment area is area of the sector, which is theta by 360 into pi r square, minus area of OAB. What is area of OAB? That we calculated here. This is becoming as an equilateral triangle of side 28, and the formula for equilateral triangle area is root 3 by 4 a square. Straight away. Here, A is nothing but our radius of the circle. So that's what we found. And if I subtract this triangular area from this sector area, I will get this minor segment area. How many such minor segments I have? 6. So if I multiply the one minor segment area into 6 times, I will get the total design area. So once I get total design area into 0.35 per centimeter square, right? So into the cost, if I multiply, I'll get the total cost required to do that design. Understood? So this is kind of a complex problem that can be given to test your all the knowledge or the concepts that you have learned in these sectors and segments. So this problem touches both sector and segment and your clear understanding on how to solve this. Okay. So hope you guys understood this. I have skipped the calculations because the pi value 3.14, it needs some time, right? So in the interest of time, I'm skipping the calculations, but the concept I hope you understood, right? So, right. So in this topic, right? So what we learned, so let's do a quick recap, right? So here what we learned, the area of the sector and segment, right? So first we covered the sectors, so minor sector and major sector. So the area is theta by 360 into pi r square, and the perimeter is theta by 360 into 2 pi r. And then we looked at what's the segment. A segment is when you divide the circle into two parts with a chord AB, then the smaller portion is a minor segment and the bigger portion is major segment. So what is the area of that? Area of the sector minus the area of the triangle. That's the minor segment, right? So here, if you see, the minor segment is the area of the sector minus the area of the triangle. Then you will get the minor segment area. How to find the major segment? Total area of the circle, right? This is the major segment. So total area of the circle minus minor area of the minor segment. And then we looked at a couple of problems. The first problem covered about sector area, right? So horse grazing the field and tied with some length of the rope, right? So the length of the rope becomes radius here. If you get that hint, you can solve this problem. Okay, then we know sector area is theta by 316 to pi r square. So that we did. And now, then we looked at another problem which has both a combination of a sector and segment. So here, the design is minor segment. So the segment area is area of this sector minus the area of triangle OAB. So we found that. And how many such minor segments are there? 6. So we multiplied with 6 and then we got the total design area. And if you multiply that with our cost, then we'll get the total cost required for the design. Okay. So that's all from today's session. I hope you all understood the topic and I will see you next time. If you have any doubts, please contact me using my Urban Pro profile. Thank you.